In this video, we look at a couple more examples of antiderivatives and some of the different tricks and things that you might want to look out for. Okay, so here's a function that we've been asked to find the antiderivative of. Recall that we could be asked to find capital F of x. That's one way to say that we're trying to find an antiderivative. Okay, antiderivative of the function given. Or the notation we could use is this long S symbol. Here's the antiderivative notation. And if you want to find the antiderivative of 2 minus 3x squared, that's the function you put. And we need to fill in the blank. Both of these say find the antiderivative. Okay, now what might be involved in this problem is sometimes a first step, step 0, might be that you could be on the lookout for some algebra. And the reason that I'm looking out for some algebra is because the only thing I know at the moment is the antiderivative of x to the n power. Okay, this is called the power rule for antiderivatives, and the answer is x to the n plus 1 divided by n plus 1. And then if we want the most general antiderivative, we could put plus c. So for example, here's something that we know. We know that the antiderivative of x to the 4th is equal to x to the 5th over 5 plus a constant. Or another way to write that is that if the function given is x to the 4th, then we can say that the antiderivative function is x to the 5th over 5 plus a constant. Okay, so that's what I know. But the given problem here, the problem as stated, doesn't look like x to the n power. It looks like a composition of functions. What we're seeing in this problem is an antiderivative of some function f of x to the nth power, in this case n being equal to 2. So it's the fact that we have a function of x here and not just x that makes this me worried about doing the power rule. Okay, because we haven't figured out the chain rule for antiderivatives yet. So there is an algebra step that could be done here, and that algebra step is to take 2 minus 3x squared and treat that as 2 minus 3x times 2 minus 3x. In which case you would get 4 minus 6x minus 12x plus 9x squared. Okay, and now we can say that the problem that we need to compute is the antiderivative of 4 minus 12x plus 9x squared. And that is an easier function to find the antiderivative of because we know what has a derivative of 4 is 4x. What has a derivative of 12x is 12x squared over 2. Basically, I'm using the power rule 3 times, plus 9x cubed over 3. Then if we want the most general antiderivative, we put plus c on it. So there's one example of an antiderivative that the key to the problem is doing some algebra. Okay, let's look at another problem now. All right, so let's look at a problem that involves maybe a little bit more algebra. Okay, so here is the given function. And we've been asked to find an antiderivative. You can find this, or the notation, which is quite a bit more condensed, is to find the antiderivative of 3x to the 1/2 minus 4 divided by x. Right? And again, this will be an algebra style problem that would be good to do for step 0. And again, the thinking is that what you know is the antiderivative of x to the n is x to the n plus 1 over n plus 1. We know the antiderivative of, for example, x to the 1/2. Okay, this we know by itself is x to the 1/2 plus 1 divided by 1/2 plus 1 is equal to x to the 3/2. Dividing by 3/2 is the same thing as multiplying by 2/3. So we know this antiderivative by itself. The problem is that we have something that's quite a bit more complicated to look at here. Okay, and so we need to try to get this problem down. The goal is to make this problem look like the antiderivative of something plus something else, so that when you get each of these different terms, you can use the power rule for antiderivatives on it. Okay? So that's what the algebra is going to accomplish for us. So let's take a look at that now. 3x to the 1/2 minus 4 divided by x is the same thing using algebra, reversing, finding the common denominator. This problem has a common denominator, and we are trying to undo that. So here is some algebra. This is the same thing as 3x to the 1/2 multiplied by x to the -1 minus 4x to the -1. Finally, you get to add exponents. 1/2 added to -1 is -1/2 minus 4x to the -1. So here is the end of step 0. You have finished the algebra, and notice that it is, as promised, of the form something plus something else. And each of those terms is of the form x to the n, where n is some number. Okay, so now we can complete this problem, okay, by let me see how much. I'm going to just add another page below this one. So we have done the algebra necessary. We've shown that this is the same thing as f of x is equal to 3x to the -1/2 power minus 4x to the -1. And now we are ready to compute the antiderivative of it. The antiderivative of 3x to the -1/2 minus 4x to the -1. And we get to use the power rule, add 1 to the power -1/2, and then divide by that same number, minus 4x to the -1 plus 1 over -1 plus 1. Okay? And we can see what happens here if we made any mistakes. So you get 3x to the 1/2 power divided by the 1/2 power. Dividing by 1/2 is the same thing as multiplying by 2, so you'll get 6x to the 1/2 minus, and here is something that we need to be worried about, right? You would get 4x to the 0 over 0. Okay, and that's a sign that we've divided by 0, and I'm a little nervous about that, right? Dividing by 0 is bad, right? So maybe when we did that power rule, this was not a good idea at this step. Okay, so we need to go revisit this problem. What is the antiderivative of 4 divided by x, or -4 divided by x? Okay, can you think of something that you could take the derivative of? Okay, what can you put here so that if you could take the derivative of it, right, the derivative of that thing, that you would get -4 over x? Fill in the blank. And the answer is that the problem has to have a logarithm. The derivative of the logarithm is 1 over x. But the logarithm gives you 1 over x, and if you want the -4, you have to put -4 on this problem. So here, what should go here is -4 natural logarithm of x. Okay, let me unlock my screen here. Okay, so there we have our answer that the antiderivative of this problem is equal to 6 square root of x, x to the 1/2 is the square root, minus 4 natural logarithm of x. And that is the antiderivative of the function f of x, where f of x is equal to this one. Okay? Our last integral to take a look at, our last antiderivative, I'm sorry, okay, is this problem down here, number 33. Okay. What we're looking at in number 33 is a given function. Find the antiderivative, okay, or find the antiderivative of e to the x plus 1 over x square root of x squared minus 1. Find the antiderivative here. Okay. Now you're looking for the answer, and the answer is what could you take the derivative of to get e to the x plus 1 over x square root of x squared minus 1. That's what we're looking to do. Okay. You know part of the answer because you can see the e to the x here, and you know that the derivative of e to the x is e to the x. Here is a complicated looking expression, and we're trying to figure out what you could take the derivative of to get x 1 over x times x squared minus 1. Okay. And to do this, I'm just going to recollect us back to something that problems we had done in the past in the derivative section. And this is why we can't forget our derivative information, is that antiderivatives and derivatives are very much related to each other. And what we're seeing in this problem is that the derivative of the inverse cosecant is negative 1 over x times square root of x squared minus 1. It's this minus sign that is what's getting in our way of the answer, but this should give us a hint as to what we can take the derivative of to get 1 over x times square root of x squared minus 1. And we knew that the derivative of those inverse trig functions, that the difference was the trig function and its co-function. So what goes here should be the inverse secant. The derivative of the inverse secant is positive 1 over x times square root of x squared minus 1. So our answer to this problem is e to the x plus the inverse secant of x. That is the antiderivative of the given function. Another way to say it is that if the function f of x is equal to something given, then the capital F, being the antiderivative, is e to the x plus the inverse secant of x. So ends this video on practicing more antiderivatives.